Hello everybody and welcome to another video in the Reclaim the Stack Getting Started series. In this video I would like to show you a tool that we built at my news desk to help bootstrapping and managing Talos Linux servers on Hetzner. So we call this application Talos Manager. You can find it here on the Reclaim the Stack GitHub organization. This video will be divided in a few chapters, so you can use the YouTube chapter feature to jump ahead to whatever section you're interested in. And we'll start with an introduction to why we built this tool in the first place. So if we head over here to the Talos Linux documentation, we can find here the documentation for setting up Talos Linux on Hetzner Cloud. So scrolling through here, you can see that there are quite a few steps and fairly technical ones. You have to build an image that you can make a snapshot with, which you can then use to bootstrap your cloud servers. And you have to generate the machine configuration files for your control plane and your worker nodes. And these files are quite large YAML files with a lot of information, including some secrets, the certificates which you use to connect and administrate the nodes with. So apart from just going through these steps and figuring out what to do, you also need to figure out where to store these configuration files in a secure way, and also how to keep them up to date when you make changes to the cluster as you progress with your bootstrapping. And if you also are deploying on Hetzner bare metal, you need to take configuration even a step further, probably by adding some VLAN and private network configuration and such things. So that's why we built this tool, to help us to quickly bootstrap clusters and also to avoid making these minor mistakes that can happen when you try to do all these steps manually. To start off, we are going to deploy this application, and we can go ahead and clone the repository as the first step here. And I will open up VS Code, and we should be able to just follow along the README. We have a deploying section here. So for the first thing we want to do is to create an SSH key, which will be used by the application to bootstrap the servers. And it's important that it's created using the PEM algorithm. If you use the default ones these days, they will not work with the current version of Ruby OpenSSL, which is also used by the application. So it's important that you do it the way we have documented here. And once you have your key, your private and your public key, you should now add them to Hetzner. So the robot part of Hetzner is where you do your bare metal stuff. So the way you would do this is go here and go Talos Manager. And the name is important. We will look for this key by using the name. So make sure you also get the name right. Now we can just copy paste public key in here. And then we're done with the robot key. Then we can head over to the cloud. And here I'm going to create a new project, reclaim the stack. And if we head in here, we can go to security and SSH key, add, and again, can copy paste the key. And let's name it Talos Manager and add it. Cool. Now we're going to follow some steps here to deploy the application to Heroku. You can use whatever hosting you want, of course, but Heroku is an easy place to get started. That's also what we use at my news desk, since this is the tool that bootstraps your Kubernetes cluster. It doesn't really make sense to deploy the app into Kubernetes because it's a chicken and egg kind of situation. So we'll start here by running the Heroku create command. The stack has to be container because we're deploying Docker files. For region, we will use EU because we are in the EU, but you can use US if you like. For add-ons, we will use the Crunchy Postgres database. You can also specify team. I will use my newsdesk DevOps team, and then we'll name this Talos Manager test. So there we go, we have the application created, so we can proceed. So the cloning part here, we already did, and we are inside the repository, but we can do this part, which is to add the git remote, and we will then use the name of the application that we used here. You will have to use a different name because these need to be globally unique across all of Heroku. So for example, Talos Manager, and just use your own suffix. And once we now have sort of connected this repository to Heroku, we can start running the configuration commands. And the first thing, we'll set up some kind of standard Rails variables and some secrets. For the secrets, we use this trick by getting some random data from dev urandom and piping it into MD5. We get 35 characters, random characters. So that's kind of a simple way to get some secrets configured. Next, we will set the database URL, which is the URL that Rails looks at for connecting to Postgres. And we set this to the Crunchy database URL, which was provided by this Crunchy Postgres add-on. Now we will go into the Hetzner API tokens. So first off, we have to get a token that we set. So let's open up a new tab here, go into Reclaim the Stack, Security, API tokens, and we can generate a token. Let's give it a name, Talos Manager, and it has to be read and write. Now we can copy that. And we can grab this part and set the Hetzner Cloud API token variable. For this demo, I'm not going to go into the metal servers because for the robot part of Hetzner, you cannot really create multiple different projects. So if I did this, it would end up exposing all our metal services, servers that we have, including the IP addresses, and I'm just going to avoid that right now. But feel free to do this on your own deployment. Now we'll set the host, and the host is the public host that you will use for the application. Most likely you will end up configuring this on your own domain, but just to get started here, we'll use Heroku app, which is the URL that you just get for free from Heroku. And next we will set the private key here that the application will need to connect to the nodes that we spawn. And we just cat the value from the Talos Manager PEM that we created. And finally, we can set a basic auth password, which is just a very simple way of getting some kind of authentication set up on the application. Now, before we actually push and deploy the application, we want to make sure that the Crunchy Postgres cluster is actually ready. We can quickly check that by trying to connect via PSQL. So it looks like it's still getting created. So one thing you can do to keep track of the creation process is to open up the dashboard for this add-on. And in here, you should be able to see clusters. I think this is the one, yeah. So we can see that the status is still creating here. So I guess we'll just wait a while for this to become available. So see you then. So we're back here. I have refreshed the page and we are ready. So we can now proceed with the next step, which is to push the app. Now the build process takes a little while. We have to build Docker here from scratch when we push to Heroku. And unfortunately, the Heroku Docker builder isn't very fast. Also, it doesn't do any caching. So when you do changes to the app and you redeploy it, you have to wait for the full build time again. Just to have some idea of what is going to happen here, we have a Heroku YAML where we configure that we have a web image, which should be built via the Docker file. And we have a single process that needs to be run, and that is the web server through this command. And every time we release, we also run the bin Heroku release script. And if we have a little look at that, that's just a simple bash script that either runs db schema load, if this is the first push like we're doing now, or for subsequent pushes, it will run db migrate to just iteratively add changes to the database if there are any. The Docker file itself is fairly straightforward, but one thing to note is that we have a dependency on the Talos CTL command line tool. So part of the installation is to download that into the Docker file. But apart from that, it's just a simple bundle install for installing the Ruby dependencies and preparing for running the Rails application. Okay, so there we are. We have successfully built the application, and hopefully we should now be able to access it on this URL here. So I think I had this previously on a test run, but the value of the password will have changed. So let's go grab the password that we generated in the first config step and paste it in there. Sure, we can update that. And here we are. So here now we have the application running. We don't have any servers yet because we have not created any servers at the Hetzner Cloud UI. So that will be the next step. So here we are back at the Hetzner Cloud console. Let's head over to the Reclaim the Stack project and add a server. The first server that we are going to add is just going to be created for the purpose of generating a snapshot that we can then use to create more servers in the future. So for region or location, we can just go with whatever you are planning to deploy to. I'll just use the default. Image, you can use Ubuntu, the default again. We don't actually make use of Ubuntu in any way. We will use the rescue mode to bootstrap through the tool. For type, you want to use the smallest type because the SSD size is important for the snapshot. For example, if you create a snapshot on a 160 gigabyte type, you will not be able to use that snapshot for these smaller nodes. So make sure that you do the initial node type the smallest here. And the rest of this, we don't have to do anything. You do not have to add the Talos Manager key at this time, so you can just go ahead and create and buy. And if we now head back to the Talos Manager app, you see that there is this little button here. which you can always click to synchronize the state of your servers at Hetzner, that's both cloud and metal servers, to the application. So we can see now that this little app here shows up, and we'll want to activate rescue mode for this one. So activating rescue mode means that we are enabling rescue mode and rebooting the server. So we might be able to see that here. We can see that 40 seconds ago we activated the rescue mode. 6 seconds ago we did the server reset. So we'll give that, I guess, a bit of time to actually enter the rescue mode. But once that is done, and we refresh here, we should see that the action here changes so that we get access to the bootstrap action. And that means that we have entered rescue mode, and we have also enabled the SSH key that we have configured this application for. So now it will be able to SSH into the server and bootstrap it. So there we are. We have synced the servers again, and we now have access via SSH, and we can bootstrap. So let me just click bootstrap, and off we go. So we are now being bootstrapped. And what this means is that we are fetching the Talos image, SSHing into the server, fetching the Talos image. We are then mounting that image onto the disk, and we are mounting the boot partition, and we are rewriting the grub config so that when it boots Talos, it will actually try to fetch config from the app that we're running here. So once this server is up and running, we will see that we can have a look at the logs. We should see that we start getting requests to the application from the bootstrapping server. Actually, the last log here is from the bootstrapping job, which is still running. So it tends to be a bit slow sometimes on these cloud servers. It tends to be much faster on the metal servers, but it shouldn't take more than a minute or so, I would say. And there we are. We have now written the disk and we have completed the job. So the last part of the job is to reboot the server, and once the server has rebooted into Talos like bootstrapping mode, we should start seeing requests coming in here. And there we go, that's our first request. If we now reload this page here, we can see that we have a little yellow blinker going on here, which indicates that this server is now ready to be bootstrapped. However, this server, like I mentioned, is not really created to be a proper server, but it's just there so that we can create a snapshot or an image that we can reuse for later servers. So we can head back to the Cloud Console here, and we can head to snapshots and go ahead and take a snapshot. Give it a name, for example, Talos Manager, and I'm also using the version of Talos that we have enabled for this image. It might happen that if you're doing this like very fast, that the server will still be in a pending state, like it's still being initialized, and then you won't have access to the take snapshots button. But if that's the case, then you should be able to just wait a while and reload, and then it should become available. You might also find that this status here doesn't update, and if that's the case, you might have to manually reload the page. But now it seems to be working fine. So that is our snapshot created, and we can now use this snapshot to create additional servers. Okay, so I have gone ahead and deleted the temporary image creation server, and now we can add our real cluster servers. So we'll go with Falkenstein again, but now we have access to the snapshots tab here, and we can select the Talos Manager snapshot. And the instance type that I hope to use here is the 4 vCPU, 8 GB RAM, CPX31, and I would like to have 7 servers so that we can have 3 nodes for control plane, highly available, and 4 nodes for workers. So let's go ahead and create these. Now the process for starting them is happening here. I've noticed that this seems to take a while longer when using snapshots, like custom snapshots, compared to the ready-made ones. So we'll just let that happen here in the background. And meanwhile, we can head over here and refresh. And we can start to name these guys. So we'll go with control plane for our control plane. 1, 2, and 3. And then we'll go with worker 1, worker 2, and then something we like to do at my news desk is that we separate the database nodes into a separate type. You can do this as you like, but that's the convention that we use so that we can have sort of more serious, persistent workloads on the database nodes and more ephemeral types of workloads on the workers. So now, as soon as these servers are booted, we should start seeing them making requests, and there they all are. They are now all ready to be bootstrapped. Now to bootstrap, the first thing we'll want to do is to create a cluster. For name of the cluster, you can use whatever you like. We'll go with reclaim the stack. The endpoint is the Kubernetes API endpoint, and you can use any host name that you can control via DNS here. We will go with reclaim the stack.myusers.dev, and do remember to add the port here. It should be 6443, which is the default Kubernetes port. The Hetzner vSwitch we can ignore since we're not doing metal networking in this demo. But if you are, you might want to configure a vSwitch for VLAN. Secrets will also leave blank so that Talos Manager can generate the secrets for us, which will be the certificates required for connecting and authenticating to the Kubernetes cluster, as well as the Talos API. If you already have an existing Talos cluster that you want to import to Talos Manager, you would have to figure out how to recreate the secrets from your existing machine configs. And there we go, that's our cluster created. And this is the page where we can also download the Talos config and kube config for this cluster. However, if we try to do so now, we will get this error that we cannot actually generate these configs without a control plane configured. So the next step is to actually start applying config to our servers. And for that, the first step is to create a config. So let's just go ahead and do new config here. Let's go with reclaim the stack as the name. Install image is the version of Talos that we install. We are currently using the latest 1.3 release. And you can also specify Kubernetes version, which is also the latest release currently. You can choose whether or not to enable kubespan, which is a network feature of Talos. And finally, you have a patch field that will apply to both control plane and worker nodes. And then you have specific patch fields for control plane and worker. And these will be strategically merged into the config generated by talosctl gen config behind the scenes in this app. So this makes it quite a lot cleaner and easier to work with the configuration which is actually relevant to your specific setup. rather than all this boilerplate that you get otherwise. So if we head back here to the Talos Manager repository in the README, then we can scroll down and we have a section here with config patch examples. So we will start by just applying this basic one. So we have something to start with, where we set the Linux CPU governor to performance just to ensure that we don't miss out on any performance. And we interpolate the host name with the name of the server. And finally, we have an increase in the max map count to support, for example, Elasticsearch. We can also throw in disk encryption, which makes use of the SMBIOS UUID to simply put encryption on the disks. This is a very simple way of getting encryption at rest. We will also throw in this configuration to support the OpenEBS local PV storage provider, which is the one we use at my news desk for our Reclaim the Stack platform. And there are also some more things which we will not do, but there are examples of how to give access to a private Docker registry, which is nice if you're deploying your images to a private repo. And also if you're doing a metal cluster, like a metal only cluster, this is an interesting way to get your network configured. But for now, this is what we are going with. We can go ahead and save this. And now we should be ready to also apply this configuration. The first thing we'll want to do is to assign all the nodes to the cluster. And then with that done, we can start bootstrapping our first node. So the way I like to do this, though you could do all of them at once, I kind of like to take it a bit slow and steady. So I will just start with the first one here. And we can see that the host name defaults to the name of the server. We also get a suggested private IP, though this doesn't actually make sense for us because we're not doing the metal network setup. So we don't have to think about this. The install disk is detected as dev SDA, which seems correct. And then if we have multiple different configurations, we have to choose them here, but we have only the one, so we can just go with Reclaim the Stack. If you're importing already an existing cluster, you can also check this box because then you're already in a configured state. But since we are here configuring from scratch, then we will just wait until it gets picked up. And it seems like it's already gotten picked up there. So this node should now be bootstrapping itself using the config, which is a combination of the secrets in the clusters configuration and our patches that we put in the configs and the other fields that we assign there. Now we can head over to clusters, and to figure out what's going on here, we can download the Talos config. So I would alt-click this and also the kube config. You can also just click them normally and then you can see the output that comes. And then we can head over here to our downloads folder, and we can run the talosctl talos config, and we use the talos config that we downloaded here. And we can, for example, run get members to see, and indeed we have this successfully running Talos, which is nice to see. However, if we would try to run kubeconfig, kubectl get nodes, we see that we get an error here. And there are a few reasons for that, but one is that we haven't actually bootstrapped the control plane yet. So that's a separate command that we need to run. So we can go ahead and run that bootstrap. And this will start the bootstrapping process for the Talos node. And the other thing we need to do is we need to set up this DNS entry. So let's head over to Cloudflare and do that. So here we are at the Cloudflare DNS dashboard, and we'll go ahead and add a record to this endpoint that we created or that we configured here. So that's Kubernetes reclaim the stack.mynewsers.dev. And for the IP address, we can head over to servers and we grab the IP of the control plane that we have bootstrapped. And we make sure to disable the Cloudflare proxy since the certificate will be managed by Talos. And we save that, and now as soon as this has propagated, we should be able to see our working control plane node. Now if we try again and run the kubectl get nodes, we can see that we have our control plane 1 and the status is ready. So that's really nice to see. And at this point, getting some more control planes should be just a matter of hitting this configure. And apart from this, we can also now add these IP addresses in Cloudflare. So let me bring back the Cloudflare records. And just like we added this guy here for the control plane 1, we can now add for the remaining control planes. So this will be number 2, and then we add a third one for control plane number 3. So this is kind of a poor man's load balancer or a poor man's redundancy of the control planes using just round robin DNS. You can also use the load balancer, which is part of Hetzner cloud if you like. So you could head in here and create a load balancer, and then you would use a single DNS entry to point to the load balancer and have the load balancer distribute requests to the control plane nodes. So that's up to you. This is kind of a simple way to get started, which I tend to do. So now we can have a look if we're getting any new nodes here, and we can see that we now have control plane 2 and 3, which are not ready yet, so they are in their booting states. This one just came in 0 seconds ago. So one command which can be interesting here is to know about is the Talos CTL health command. So this will also confirm that we have 2 nodes in bootstrapping state, and then when they are done bootstrapping, then we can check with health and they should be good, and we will also find that the status will become ready over here. And there we are. So now if we run get nodes again, we can see that they're all ready. So that's fantastic, and we can now proceed to bootstrapping the worker nodes. So let's go ahead now and start configuring our worker nodes. So as we did with the control planes, we can just go and hit configure, and that should do it for us. So we do the workers, the database nodes, and we see them all go green here. So one thing that we haven't touched on yet is that how does the Talos Manager figure out which nodes to bootstrap as control planes and which to bootstrap as workers? So we do just convention by name. So if your server has control-plane in the name, then we will automatically detect that as a control plane. And if it does not, then we assume it's a worker. So that's how we do that. So now with these being green, we can head back here and we can see if we get any new nodes. So far, they have not showed up yet, but given a bit of time for the boot to complete, we should start seeing them coming online. You can also use the get members again, because we would expect them to show up here first before they are actually available to Kubernetes. And sure enough, we can see them. We could also start running the health command if we wanted to wait for the detection of boot state for these worker nodes. So it seems like we only have one still left, and that should be all of them. Let's get nodes again, and now we have our nodes nice and ready. Now the next step that we'll do is to assign roles to our new worker nodes. Now how we do that is to apply the label to the node. So for example, worker 1 becomes a worker, and worker 2 is also worker. Database 1 is a database, and database 2 is also a database. So now we should be able to get the nodes again, and we can see that they have the assigned roles. And another thing that you might want to do is to also taint the databases to prevent any non-database workloads from ending up assigned to the database. And this is done by running kubectl taint on the node. And in this case, we tell it that the role database must be tolerated to schedule on this particular node. And we can apply this to both our database nodes. And this is the setup that we run at my news desk. So we have worker nodes, which can run anything. We don't have any taints. Whereas we have also the database nodes, which are assigned the database role, as well as are given this taint of role equals database. We also actually have another taint for our production databases, where we give an environment equals production taint. So that's just an example. I'm gonna just Control C out of here now, but that's an example of how you can configure your nodes to only receive certain workloads and to separate workloads between the nodes using roles and taints. And these then of course need to be also referenced in your resource template files. And if you're using the Reclaim the Stack platform, then we do this automatically for you. For the databases, we apply this taint toleration, as well as we node select on the database node, for example. So that's pretty much all I wanted to showcase in this demo. I hope it was useful. So to recap, we created our Reclaim the Stack Talos cluster and bootstrapped 3 control planes and 4 workers using Hetzner Cloud. Something I did not go into in this demo is the dedicated servers, the bare metal servers on Hetzner. If you're doing bare metal, then pretty much everything is the same, apart from you will not be able to create the snapshot that we did in the beginning to make it like super fast to spawn all these servers connected to Talos Manager. But instead, each of the servers would show up here in the list, and you would just make sure to enter rescue mode, and then you would refresh and you would be able to bootstrap. And you would click bootstrap on all the nodes individually, and you would end up again in the sort of yellow state, and then you could do the config that way. If you're doing bare metal, you might also make use of the vSwitch and the special configuration variables that we have for setting private IPs and VLAN. But I would also like to say something about what Talos Manager does not do for you. So, for example, it's great for bootstrapping new servers, new clusters, and adding new servers to existing clusters. But it does not do like continuous updates for configuration. So if I would, for example, add something new to this configuration, like a new parameter, we do not have any functionality to apply like the new configuration on top of existing servers. So it would just take effect for new servers that you add. So you would use something like Talos edit machine config for your existing nodes. There are also other talos-ctl commands for patching many servers at once. So those are the things that you would use to iterate on your configuration. But I would recommend, like, whenever you iterate and you make a change to your servers, then you would also apply the change here, so that when you add new servers, it's easy. And it's also like a way to see an up-to-date version of the configuration. So that's it, I think. So thank you for watching. I hope the tool is useful. If you use it, then I would love to get feedback and hear how your experience is. If you run into any bugs, then please let me know as well. You're always welcome to chat about these things in the Reclaim the Stack Discord. So hope to see you there. Thank you.